Hello everybody and welcome into my latest live video. It's the last day of October, October 31st, Halloween 2022. My name is Kerry Holzman and thanks you guys so much for tuning in for today's video. We're doing something a little different today, and as I've promised, there are benefits to membership, and what I'm going to do in order to avoid some of the chaos that occurs in the chat room along with the distractions is from time to time, starting with this video, live videos of certain content will be made available without monetization and live only to members. So people who are not members won't even be able to watch it while it's live. However, after the video is live and after YouTube has processed it, then monetization will be turned on, and then public viewing will then be available for that video indefinitely after that point. So much like other things in the world, if you want it first, you want to go see Black Adam at the movie theater that's playing right now, the only way you can watch it is at the movie theater, and you'll pay that ticket price. Likewise, the new processors, both from AMD and Intel, that just came out are the highest price they're ever going to be. And in a few months' time, they'll be much cheaper. So we're going to follow that business model, and hopefully it will establish some value to people who, for whatever reason, don't find value to support the channel, but find the value enough to watch every video. And I appreciate those viewers, but I also really appreciate the supporters, and it's time I start to show that and show the difference. So, well, again, I appreciate all my viewers. There are a small percentage of you that make many of these videos possible that otherwise I would not have the funding. Instead, I would be making sponsorship videos for manufacturers, which is essentially long commercials. I don't want to do that. Either that, or I drop this kind of topic because it's so expensive to make these videos, to get the hardware, and move over to a different subject matter that, like cooking. You know, I can make a video with $6 worth of ingredients that generates the same amount of revenue as these videos. However, what I'm trying to do here is share over 30 years of experience with you guys in the hopes that it can inspire you, encourage you, and more importantly, by showing it live, you'll see that errors are commonly made along any build or repair or upgrade process. It's part of the job. The difference is a professional, somebody who's had years and years of experience, it's like not a big deal. It's not a, oh, stop the presses, a mistake has been made. It's like, oh, here's a little mistake, we correct it. Very, very rarely is a mistake ever made that's so drastic that it requires the build or the upgrade or the repair to stop until new parts, replacement parts are ordered for damage. Typically, they're more about embarrassment or ego or pride than they are about the reality of, people making a big deal out of what is essentially nothing. And I don't think other YouTube channels are doing you a service by editing out all their mistakes. And they make mistakes. Everybody makes mistakes. If you didn't make any mistakes, you'd probably not be interested in doing it. It would pose no challenge to you. It would be boring. You couldn't be bothered. Like a video game that had no challenges. You just move the little character on the screen from the left to the right with no obstacles. And when you're off the screen to the right, you've won. Does that sound like a game you want to play? Because an edited video is perfect. It should be. All the mistakes can be removed. If you misspeak and you catch it, you can go back and correct it. When it's live, it's real. And for those of you who appreciate reality, because it seems it's in short supply these days, everything's about virtual reality, everything's about being online, everything's about Instagram and, things that are what people want you to see versus what's really there. And so I realize this may be a condition of my age. I grew up as a teenager in the 80s. And so these values from people today that only want to show perfection and lie, they're effectively lying to everybody about what it took to get that Instagram shot or what it took to get that video made, to get that computer built. They only want to show you the highlight reel and not watch the entire sportscast. Some people are just highlight reel people. If you are, this isn't the channel for you. However, I will say I do have a quick tips channel. I don't upload to it very often these days, but too many people can't be bothered to take the time to learn. They're not interested in learning. Just give me the answer I want. Don't show me how to do the math. I'm not interested in learning math. All I'm interested in is the solution to this math problem. And I'm not interested in enabling people to remain ignorant. I'm here to motivate you and to help you. And sometimes I'm a bit tough about it because I believe in you and I know you can do it. Sometimes some of the questions are like, I'm asking myself, did you even try? I hope you did. I hope you try. And if you try and you don't succeed, so what? You come here, you join us in the chat, you let us know what you're trying to do, what you've tried so far that hasn't worked. This is how we learn. This is how we understand the misconceptions that can help teach people in the future. Because whatever mistake you've made likely has been made by others, but everybody wants to be embarrassed about it. Everybody wants to hide their failures. I'm not suggesting you should boast your failures, but what I am suggesting is it's just a part of life, and to deny it or give it less value than successes doesn't make any sense to me. We cannot have those successes without the failures. Many successful business people tried numerous businesses that filed for bankruptcy and failed before they got one right. And this goes all the way back to Henry Ford. Henry Ford had multiple attempts at starting a car company that ended in bankruptcy. Elon Musk almost ended in bankruptcy with SpaceX and Tesla. It was this close. So there's a certain amount of risk you have to be willing to put out on the line in order to receive a certain kind of success. So I don't know why this has to be said, but from what I see in the comments and sometimes from what I see from reactions from people in the chat room, it does seem like we're starting up from the complete wrong, opposite ends of a page here in understanding what my goal is and what my purpose is in making these videos. I absolutely do not want to feed a man a fish. I want to teach a man to fish so that man can feed himself. So I hope you can appreciate why I do what I do and what it is I'm trying to accomplish. And again, for this video live right now, it is members and moderators only that can jump into the chat and watch this video while it's live. Once the video has processed, when it's over, then it will be made public and monetization will be turned on at that time. And I will be doing this not for every video, but I will be doing this far more often because membership has its benefits, and this is one of them. And I want to just let you know how much you guys mean to me. I'm always having to defend myself, and I know when I make a video open to members only for viewing and commenting, I won't be defending myself because you guys don't do that to me, and I appreciate it. I also expect we're going to have a smaller turnout. That also means that if you have a question for me, I will be more likely to see it, and I want to make sure that those who give, that I also give back to, especially because without you guys, today's video, for example, wouldn't be possible. I have a $150 NVMe drive. I have a $310 CPU. I have some RAM here, 16 or 32, I don't know, I just grabbed it. In this case, I've already had the RAM, but somebody's paying for all of this. This motherboard, this is a Z690 AORUS Elite AX DDR4. This is a Z690 motherboard. This is $199 plus sales tax. Now, a lot of people think, well, you're making that YouTube money. That's right. And with the YouTube money, I can buy groceries. But what I need to be able to do is spend 2 to 3 times my YouTube money monthly just to have the hardware available to make the content. And then I have to try and sell that hardware, which I typically have to take at a loss, plus all of the labor I have to put into cable management, the ongoing support once it's sold, the packing it and the shipping of it takes hours and hours and hours out of my day, and I cannot be making content, ordering parts, selling and talking to people on the phone for selling things I've built, and then loading up the car and driving it over to FedEx and waiting in line there, which is only going to get busier come the holiday season. I am my only employee, and as a result, you'll see certain times of the year I get pretty frazzled. I am stubbornly marching forward, but lately I've been dropping the ball a lot. And so I'm aware of it. I need to make a correction, and things will get, I want to say, back to normal. Ideally, there will be a new Studio C before long, and that will be a huge step forward in how I produce videos moving forward on a regular schedule besides Fridays. I'd like to have at least 3 days a week where I'm doing scheduled videos, which is impossible for me to do here. So anyway, that's what's been going on. And I just realized I don't have a cooler. So let me just step in the other room and I'll grab a Scythe Mugen 5. That's a $65 cooler. This computer is only purchased to make this video. I want you to understand that when I talk about the expenses involved, it's going to be my problem after this video to try and figure out what to do with this. The reason is because there's going to be a lot of people, I imagine, who are interested in buying the latest 13th generation Intel, but don't necessarily want to buy the 700 series Intel chipset boards because they cost more money, primarily. I was mistaken and I was corrected that the difference between the Z690 and the Z790 boards are not what I thought they were. The Z790 I thought was DDR5 only. In both cases, in the Z690 and the Z790, you can get the boards supporting DDR4 RAM or DDR5 RAM. The 700 series chipset is nearly identical in almost every way, except if you get a DDR5 motherboard, that's a 700 series, it'll support higher RAM speeds, which for some people that matters. You get more lanes of traffic for your PCIe Gen 5. Since we don't really have anything that's PCIe Gen 5, it doesn't really matter. But if you were to, for example, have a PCIe Gen 5 NVMe storage drive and a PCIe Gen 5 video card, they would likely be sharing the same data paths. That would not be ideal, right? You'd want to have multiple data paths. So for most people, I don't think it's really going to affect them. You can absolutely go to a Z690 and really not notice it. There may be a couple of other differences from one board manufacturer to another or one model of board to another, but I leave that to you to do that research. And if I've left anything out, any comments, preferably with a link to provide evidence to what you're claiming, is very helpful for me to understand when somebody is making stuff up versus when there's actual facts. I have been so split with my time. I'm normally more on top of the ball with all the latest hardware. I was surprised at just how little difference there was in the 700 series. But here's what happens, and here's why we're making the video. This motherboard came out, what, 6 or 8 months ago, whenever it was, when the 12th gen processors came out. I don't even remember when that was. But the 13th gen did not yet exist. So how does this board know to recognize a chip that didn't exist when it was designed? It's entirely possible that the motherboard BIOS was updated at the factory already, so it will recognize the 13th gen chip. We don't know. But I'm going to assume that this BIOS is older. And if so, how do we update the BIOS on this motherboard so it will recognize not just the 12th gen, which what it was designed to do, but also the 13th gen? Now, this is a very similar process. I've covered this with AMD Ryzen chips. It was very common with the AM4 motherboards to all have that backwards compatibility. You had to upgrade a BIOS to get that latest Ryzen chip to be recognized by the board. I've also had to do this with, I think we did it with Threadripper, and I think we did it with X299. With ASUS, we use something called BIOS flashback, where you don't even need RAM or a processor to flash the BIOS. I don't know if ASUS introduced that, but ASUS is commonly the one that introduces the technologies that the other manufacturers of boards start to mimic it. JJ from ASUS was sure to let me know that, to say, just pay attention, Kerry. Watch what we do. Watch how we're the only ones who are doing it right now. And in a few months, watch how all our competitors start doing this. So he's not wrong. And I think BIOS flashback was originally an ASUS thing. So how do we do it on GIGABYTE? And how do we do it without a processor that will be acknowledged? In the AMD Ryzen days, well, we're still in the AMD Ryzen days, but in the AM4 socket days for AMD, the solution was get an older AMD chip, just borrow it, whatever you have to do, so the machine will recognize that chip, then flash the BIOS, then take that chip out and put your newer chip in and it'll work. And we can still do that today. You can buy a low-end Intel socket 1700, what is it, a Pentium G chip, relatively cheap. But if you're going to do that, why not just buy the 700 series? Presumably you want to save some money and you're not going to see any benefit from the 700 series anytime soon. So this is really done for financial savings. That's why people do it. Now, the BIOS flashback on a GIGABYTE board, and especially a 12th gen board, never done it before. I've done similar things. It's not like it's a foreign concept to me, but I want to tell you right out of the gate, I've not done any research. I've done no rehearsal. I've done nothing to prepare myself for this. As a field service technician, when I'm called to go on site to a customer's location, I never know what I'm going to encounter. A customer could have an aggressive dog. A customer could have a 10-year-old computer. A customer may have built something themselves which has 4 video cards in it and only one of them actually is working. You never know what you're going to run into. I might run into a Dell or an HP or an Acer pre-built that I've never seen before and can't even find the power switch, right? But I'm on the clock and I'm paid by the hour, and it's very expensive for the clients to pay that. And the clients don't want to see you bumbling around. So I have to get in there. I have to sort of reverse engineer using my past experience and find what's familiar. For example, I know it's going to have a power button somewhere. I know it will. And so all of that parlays into what we're going to do today, which is just as though a customer were to call me, say, I've got the Z690 board and a brand new 13th gen chip. I've got my RAM, my solid state drive. This thing will not fire up. The fans spin, the lights light up, but I get nothing on the screen. Can you help me? Not all motherboards support BIOS flashback. I will tell you, BIOS flashback was what ASUS called it. I don't know what GIGABYTE's calling it, but it's the ability to update a BIOS without a working processor installed on the board, or a recognized processor installed on the board. It's really, really cool. However, it's very, very specific. The BIOS must have a very specific name. The flash drive must be like an old school, quite often USB 2, FAT16, or just FAT file allocation table, no NTFS, no exFAT. System won't read it. The BIOS has to have a specific name. You're going to have to change the name of the BIOS, and it'll tell you what you need to change the name to. If you've ever watched a video here on YouTube where somebody has downloaded an ASUS BIOS and there's this little batch file to rename that BIOS, they're wasting their time. The only reason you would ever have to rename the BIOS is if the system won't boot and you're trying to use the BIOS flashback. So it drives me crazy when I watch YouTube content creators following an unnecessary step. It's not hurting anything, nor is it helping anything in those instances. So be aware of what you're watching and ask yourself why. Why did the person, like if you have to download and rename the BIOS, why didn't they just name the BIOS that from the beginning? It's a very simple question. So the BIOS name will never change for the BIOS flashback. It is looking for something specific, but the BIOS names change every version, you understand? So normally if you can just update your BIOS with a bootable computer, you do that going into the BIOS or through a Windows utility. You don't have to rename that BIOS. And that's going to be universally true. I've never seen a manufacturer that did it any other way. So I have no idea what the current process is on this Gigabyte board, but I will tell you there are some things in common that we should expect. There's only going to be one USB port we can use. Despite the fact there's many USB ports, one will likely be a different color or have some kind of a box or draw attention around it for the BIOS flashback if needed. Again, we want to use a small, older USB 2 flash drive, no NTFS. If you don't follow the instructions exactly, it likely isn't going to work. Now, I'm not going to say it's going to damage anything, but it might take you far longer to accomplish what you're trying to do if you rush through it or you make assumptions. This is an uncommon activity, especially with Intel. As a result, making sure you do it right will likely get you done sooner rather than later. And it's relatively the same, as I mentioned, across all motherboard manufacturers that support the ability to update a BIOS without a working CPU. It's absolutely incredible that it's even possible. But again, not all boards support this feature. Typically only more expensive higher-end boards like the Z series boards for Intel. And even then, only recently, within the last few years. 10 years ago, I don't think such a thing was even I don't know if it was a thing 10 years ago. Time flies when you're having fun, so I don't remember the first time I had to do this. On a lot of the discounted or cheaper, less expensive AM4 socketed AMD boards, there's no such feature. It would add cost to the board. Therefore, you have no choice but to use an older CPU for compatibility to be able to update the BIOS in a traditional manner. Okay, so welcome to all my friends in blue joining us on the video. And I see Patrick Manny, Patrick Russaw, Mark Baggett, Elijah Dickens, and Joseph Winterhalter joining us. And it's nice. I like we have a nice little intimate crowd here. And it's much less chaotic. All right, so the first thing is, this video is going to end real quick if I pop that chip in and it just works. I'm hopeful that this is an older BIOS. The longer you wait, if I wait 6 months and then I buy a Z690, assuming they're still available for sale, likely it will already have the BIOS on it that we need to recognize 13th gen chips. Except newer 13th gen chips, models that aren't out right now, will be coming out. I think 8 or 9 more models are coming out sometime in the first quarter of next year. So even the BIOS we update to today won't know those chips coming out, I think. So even if you do get the latest BIOS, it depends on how new your chip is compared to how new your board is. That will determine the likelihood if you need to follow this process. All right, I think I've got all the caveats down. Now this board looks nearly identical to the board that Mitch and I used on Friday's show. And at a casual glance, it looks like all the same specs. This is an AORUS Elite AX DDR4. It has built-in Wi-Fi, just like the other board. It takes DDR4, just like the other board. It is a Z690 full-size ATX motherboard, just like the board from Friday, and it sells for $199 at Amazon, just like the board on Friday. I haven't really taken the time to compare the two boards. I think the Wi-Fi on this one's a little faster, but again, that requires you have a compatible router. Otherwise, you know, if you don't have a router that supports AX, then whatever your router does support will be the limit to how fast this Wi-Fi can go to today's standards. So whether or not that's important to you, as far as I can tell, the boards are nearly identical. I'm not quite sure how Gigabyte justifies two models at the same price point that are identical in almost every way. But again, I have not done the research on it. However, the process should be the same regardless. And let's find out what happens here. So we've got our brand new board, and bring this down here. Actually, I should go ahead and get my M.2 screws out of here. Well, they gave us more cardboard on this one. They gave us This went flying. You know what? Look, maybe we get the handheld camera out here. We'll get you guys some close-ups from this point forward. Since I've got all the disclaimers and heads up of what to expect out of the way here, I think I can actually get to work. We've got our antenna, M.2 screw. This board only has 2 M.2s. The other board had 3. There's a difference. No, wait a minute. No, wait. There's a third one. There's a fourth one. Oh, well, in that case, let's go the other way. This board has more than the other board had. I'm not quite sure. I haven't even looked at the board yet. I'm making some guesses here, but we have 4 bags with these little M.2 screws. And in the Friday's build, we had 3 bags. Same price for the motherboard, Z690 both ways. After the show, I'll put a link to both boards and you guys can compare them. Decide which one's right for you if you're in the market for it. And before I open this up, let's get switched over to camera number 3 here. Camera 3 is our close-up camera. Put the cam girl to work. There we go. You're good. Come on in. All right, so these are our bags. Of course, this drives me crazy for the garbage that it creates. You know, not like they couldn't put the one screw there. 4 of these screws in one bag. This is somehow they do inventory. I bet you it costs more to package these screws individually than the screws themselves cost. So that's to prevent them from losing money. God forbid they gave everybody 4 screws, whether you needed it or not. They'll spend more to give you less and create more waste. You gotta love corporations. All right, we've got the board in an anti-static bag here, so let me grab some scissors. GIGABYTE likes to tape the bags closed. I don't know other manufacturers that do that. I'm not quite sure what taping the bag closed accomplishes, because once it's in the box, if the bag is folded, there's no way for the bag to open. And I just find it bizarre. It's a more unnecessary waste. Now this board is significantly heavier than the board from Friday's show. This thing weighs, I don't know what it weighs, but it feels a good 3 or 4 pounds, nearly twice the weight of Friday's build. And we have a much larger heatsink here on the voltage regulator modules around the CPU. We have these little pull tabs. You see the blue? They want you to remove this plastic. You see there's some blue here. This is designed to keep surface areas of the board, particularly that have a brand name on them, from getting scratched in shipping. By leaving these plastic pieces or these plastic sheets on, it's interfering with the efficacy of the ability for this heatsink to dissipate heat passively, right? So we've got some plastic here on the side. And again, this really doesn't affect anything other than looks. The plastic, if you don't remove it, it will start to bubble and turn yellow over time, and it just looks terrible. And given today's common desire for people to want an attractive system, I'm just noticing something that JJ pointed out to me. JJ said ASUS was the first to introduce the metal-supported PCIe slot for the weight of the graphics card. Also, you'll see metal-supported DIMM sockets. What's interesting to me is they only support 2. There's metal supports on 2 of these DIMM sockets here. You see this metal, and you see the metal around the PCIe. Now, I've never seen a PCIe crack. I don't know what problem this is solving. It seems a bit over-engineered, and I'm okay with over-engineered. But again, I'm always asking why. Why do they do this? And there's some psychological impact of quality by reinforcing this area where there's typically going to be a graphics card which will be very heavy, especially if that's a 4000 series graphics card. And the RAM, RAM can be pretty tall, and you're in a little socket that's, maybe 1/4 of an inch deep, if that. So you can see the leverage of that thing tipping over and splitting or cracking the socket is potentially there. However, I've never seen it happen in my life. These heat shields, we've got likely there's 2 M.2s under here and another M.2 under here. If you were to buy an NVMe drive, you would likely not want to use an NVMe drive that already comes with its own heat shield, because it'll interfere either in this socket or this socket with seating your graphics card down. Also, aesthetically, these heat sinks, these are much more visually appealing, and you will save money by buying an NVMe drive that does not come with a heatsink. If your board already provides it, there's not a whole lot of cooling difference between one and another, generally speaking, and of course there's always exceptions. If we look on the board, what are we getting on this board? I see we have a USB 3.2. Oh, don't worry, the USB 4 standard has been ratified and will be coming out soon, as will Thunderbolt 4, and everything is backwards compatible. We have a USB 3.0 port here. I'm assuming that's 3.0, but maybe that supports a higher USB range. I'm not sure. We've got 6 SATA ports, which we're not going to use any of. Right along the edge here, if you look, we've got 6 of them. That's our CMOS battery there. We got a lot of fan headers all over the place here. 1, 2, 3, 4 fan headers across the bottom of the board. 1, 2, no, that's not a fan header. 1, glasses, Carrie, glasses. 2 fan headers, 1, 2, and then these are for LEDs. If you're going to hook up external RGB lighting, and you want to be able to control that through the manufacturer's app that you can download. We have a screw to mount this motherboard, and I don't know how well you can pick that up. It's right there. This is going to be in the way of that. That's disappointing. I don't like it when I have to remove something to get to something as basic as the motherboard mounting screws. This has to come off anyway for our NVMe drive, and I just need to remember to keep it off until we mount the board, or I'm not going to be able to get access to that. Because what I'm doing today, I'm going to do outside of the case, I guess I'm going to have to put this back on anyway. But that means I'm going to have to take it back off when it comes time to putting this in a case. We've got 2 additional PCIe slots right down here. We have built-in Wi-Fi. If we take a look at the back, now, if this supports upgrading the BIOS without a working chip, which USB port do you suspect we would need to use? Do any of those ports stand out? Boy, will I be embarrassed if this board doesn't support it. Again, I'm making an assumption here that all these Z690 boards from GIGABYTE and ASUS will support that, but they might not. Yeah, go ahead and get a close-up of that. Because I'm not seeing, but I can't read the little words there. Let me see if I get a little closer. Oh, BIOS USB 3.2. You see that red? So she's right on the, you'll see the Wi-Fi antennas on your left. You'll see 4 USB 2.0 ports at your far left. In the exact middle of the screen, you see 2 red USB 3.2 ports. The very bottom one, if you look closely, says BIOS. To the right of that, you'll see an HDMI output and a DisplayPort output. You'll see a USB 3.2 Type-C and a 3.2 Type-A. The Type-A is the one you're most familiar with, the Type-A. That's the wide rectangular one. And to the right of that, 2 more USB 3.2s in blue and the red 2.5 gig LAN network card. And then we have surprisingly very little audio out. Typically a board of this level supports surround sound. Do we even have a speaker out? We have SPDIF, that's optical. We have a microphone input. We have a line output. We don't have a speaker output. Typically on boards of this caliber, I'm accustomed to seeing 6 circular holes for audio, for rear audio, front audio, subwoofer, center channel, 7.1 surround sound. This, on the other hand, looks like it's taking a completely different approach. I'd have to look at the specs of the board to see what level of audio it's supporting. but apparently we're just going to be using the line output. And you'll see the I/O shield's already put on for us. That's one less step we have to deal with when we're installing this into the case, which we won't do during today's video. And yeah, those are great shots. Thank you for doing that. So the first thing I want to do is I want to get these little M.2 screws out of these bags. They're so easily lost, misplaced. Most of the time people only take what they need when they're building and they put the rest somewhere thoughtlessly. And then months or years later, they need to find it. They don't know where it is. So what I like to do is what I wish GIGABYTE did, which is just go ahead and put these on the board where they go and leave them empty. You know what's troubling? Do you see the recycling symbol on that? That's a number 7 that says other. What that likely means is this just goes into the garbage. If you look up, if you Google what these numbers mean inside of the little triangle of arrows on recycle, you'd be surprised how much stuff that is claimed to be recyclable may not be recycled by your municipality. And it worries me that it says other, that it's not specific about what the material is. So that's why I say, you know, to put all these screws in these little bags seems quite wasteful, and you know, it is adding to the cost of the board. So it's not like it's free. So I've got the 4 screws out, and I got to figure out where they're all going to go. So we're going to take these heat sinks out. These heat sinks, they use a very small screw similar to the M.2 screw, in that the heads on the screw are not exactly American standard Phillips. These are Japanese Industrial Standard, JIS. And I've got a couple of JIS drivers here. This is a Hosan 550. I bought one on eBay. Screwdrivers, you know, I'm always cautioning people about buying electronics off eBay because of, you don't know what's fraudulent or returned or damaged. Screwdriver's pretty safe buy, get some pretty good deals. I found this one. This is a JIS that's a little, I was gonna say it's a little larger, but the head actually looks the same size and far more comfortable. This handle's very squishy. I've never seen it for sale anywhere. So I saw it on eBay. I said, oh, I'm gonna buy that. Because if anything happens to this one, I like to have a backup. So we'll go ahead and just start taking the heat sinks off of these M.2 slots that should be underneath. Sometimes these screws are what we call captive, meaning they don't come out, they stay with the device, which I like. You don't have to worry about them falling onto the floor and you're searching around trying to find them or wondering which screw went where. When we take this off, let's keep in mind the straight edge of it goes towards the back of the board, and the angled part is going to go towards me. No, it's not a captive screw. It just fell right out. All right, sometimes they're captive, sometimes they're not. And then if I lift it straight up, whether they're captive or not, I can keep them all in the same place. Some motherboard manufacturers will use all the same screws, and sometimes they use 2 sizes, you know, 1 size of screw on one side and 1 size of screw on the other. Depends on the make and model of the board. But this does expose a total of 4 M.2 slots. These are your standoffs that your M.2 drives are going to screw down to. This is what's going to secure your M.2. And then we've got one up here. So this is usually using a channel directly to the CPU. And then these are using PCIe lanes. I much prefer this channel first. And again, it can vary based on model. This is not a universal truth. So what I'm going to do is take the 3 little M.2 screws I've got here, and I just want to set them, oops, it's not magnetized. This one should be magnetized. Much better. I want to put these screws right in here and They don't have to be tight. I just want to be able to find them in a couple years' time or months' time when and if I want to add more M.2 drives. And if Gigabyte would have sold it to me this way, I would have appreciated that. So that's all I'm doing with that. And you'll see these standoffs here. These are what hold the heat shield down. These two, and then these holes here. These are all for holding the heat shield in place. So I'm going to just cover that back up because it looks prettier with it on. And we don't need to do any more in there. And once again, don't over tighten these, just bring it till it's snug. All it's meant to do is to mostly be aesthetic. If you have M.2 drives under it, you definitely don't want to squish them underneath this, but you do want it to make content so it can dissipate the heat generated off the M.2s. Now, for the M.2 on today's build, these were on sale. These are from a company called AData. I've been using AData stuff off and on for well over a decade, mostly flash drives. And this is their like SAM7 series, S7 series, for like $139. This is a 2 terabytes for $140. It's generation 3. So it's only going to move data about 3,500 megabytes per second on your reads, about 3,000 megabytes per second on your writes. This board is capable of doing twice that, but it would cost us about twice the amount of money, thereabouts, for a generation 4 2 terabyte drive. If it's worth it to you to spend twice as much to get the same capacity that's twice the speed, that's for you to decide. I'm not going to waste my money on it because in reality, my customers can't see the difference. Windows will still boot in approximately the same amount of time. It might be a few milliseconds faster. If you're doing a lot of input-output, if the way you use your computer, you would see that difference, then by all means, spend the extra money. But in this case, these are very, very affordable. And if we were talking a couple years ago when Gen 3 was still a thing, these are right up there in performance with the performance models. So I'm going to go ahead and open this up. I've got a link to all these parts in the video notes below the video. They take you to Amazon. If you make a purchase at Amazon using my link, I make a small commission. I don't know who you are. I don't know where you are, but I can see what was sold and when it was sold. And you don't pay any different. Nothing's any different from your perspective, but it's a nice anonymous way to support the channel, and you don't have to go searching for the part. Inside of this box, you'll notice we have a little heat sink on top of this. And I don't know if it's stuck on there or not. Let's take a look. We have no documentation. All we have is this little stick of gum sized drive. This little thin piece of metal, very, very thin, is glued to the top. And because it's so thin, I think we're okay to leave it on. My preference would be to take it off. However, there's no way I can take this off without bending it and potentially ripping the chips right off the circuit board. They use something these days called surface mount technology. You might hear the term SMT. Remember the days, if you've been in electronics for a while, the components had little legs and you shove the legs through holes in the circuit board. You solder the legs and then you cut the ends of the legs off. Not anymore. Today, the parts sit on top of the circuit board and then the solder just solders it right to the top. They no longer go through the motherboard for the most part. Few exceptions depending on the component. So I'm not quite sure that this is going to fit with this heatsink. I think it's so thin it won't make a difference. And we're just going to go ahead and set that in. It goes in on a bit of an angle right there. We want to see those gold fingers disappear. So you'll see I'm holding it at about a 45-degree angle. I give it a slight wiggle and push it. And it just sits down. And it will act like a little bit like an inverse diving board. All this little M.2 screw does, it just holds this end of it down. So be very careful not to over tighten it because it's not like it's going to come loose because you didn't tighten the screw enough. There's no vibration or anything happening here. This is a very simple function, which is simply to hold that little drive and keep it from coming out. So that's all you have to do. Then this heatsink can go back on. We want to make sure we remove the tape. There's some thermal tape here. And we remove it when we're ready to install. That keeps it clean of any dust, debris, or any contamination. We want to avoid touching it. If you do touch it, it really probably doesn't make any difference. But I would suggest avoiding that, just so you get the best thermal transfer from the top of that NVMe through this big piece of metal to, again, passively cool it. This is the little screw that came out. And working with a magnetic screwdriver is highly recommended. Back in the 80s and 90s, when we were still using floppy disks and zip disks, those were all magnetic-based media. And if you got a magnet too close to them, you would erase them, just like a VHS tape. You can put magnets all around DVDs and Blu-rays, it doesn't affect them. So there are people that still say not to use magnetic screwdrivers because they're still stuck in 1992. And I just want you guys to know that unless you are working with magnetic-based media, which I don't know, what's magnetic? Is there any magnetic-based media anymore? Tape drives, I guess. I'm having a hard time seeing where this is lined up. There is a bit more resistance, even though that heat shield on the M.2 drive is thin. It's still not quite as flush as it would be. So what I'm trying to do, I'm trying to locate the drilled hole here for this screw, and the heatsink's covering it, right? So I can't really see. So what I do is I turn the screw and I kind of move this around a little bit until I feel it sink in to something, and I'm getting like nothing. So when that happens, I have to take it off and visually try to line it up. And of course now it wants to stick to that NVMe drive because we've got the that thermal tape now. It's got a little adhesion to it. And I'm going to grab a little flashlight here so I can look down in there. And I know there's not much here for you guys to see, and I apologize for that. But it appears I'm way, way off. For some reason that I don't understand, this is too far out. So I need to start at the other side. Take another look here. From what I'm seeing, this whole piece needs to come back. I mean, if you look here, these should be in line with each other. So this has to come back more towards me significantly, like I'd say a good 1/4 of an inch, which is a lot. I'm not quite sure it wants to participate. Now, if you notice, in very fine lettering, it will say M2 slot engraved on the heatsink, so you know what's under it. And you'll see the other one as well will say M.2 slot. So again, it's not everything will be in your documentation. You can always go to the motherboard manufacturer's website and download the PDF file and see it online. Well, that's really super sticky. So that needs to go more or less right there. So I'm going to start with this side. Yeah, that's better. Now I'll come over to this side. Oh, much less effort when you do it the right way. If you're struggling with something, you're likely doing it wrong. There's something you're doing wrong. So if you've got a lot of money invested in your computer and you're struggling with something, I need you to take a breath and think about your approach. Now, we'll give this a full spin around, and you can see that, you know, even if this heatsink was thicker, these screws are designed that this little heat shield can go up or down, but it might interfere with the installation of a graphics card if you raise it too high. And then that's sort of the downside of these heat sinks. It depends on your GPU, but some GPUs may have a difficult time getting fully seated into this socket because this is a quite a distance over the end of that. I don't know if you can really see just the height difference between those two areas, but that's designed that way by the manufacturer. And if we get something level and just place it across the top, like, I don't know, a level, we can see if we're still centered. You can see that bubble. What happens when we go this way? See the way the bubble goes in the middle, this bubble right here? You can see it's slightly elevated because of that little heat shield. So it would have been better for me to use an NVMe drive that did not have that little heat shield. Despite how thin it was, it just makes the slightest little difference, which likely will not interfere with the installation of a graphics card, but it's certainly not making it any easier. So that, again, that's 2 terabytes, Generation 3. I'm trying to do this on a budget. I'm trying to keep my costs down. If I were actually building this for myself, I would likely put a Gen 4 in there if I could get a good price. So a good price on a Gen 4 2 terabyte drive would be under $200. This is well under. This is like $140. I'm not going to get close to that on a Gen 4 drive of 2 terabytes. Certainly not one that's going to perform to make it worth your while. Just because it's Gen 4 doesn't automatically mean you're going to get the maximum speed out of it. So I want you to keep that in mind. That would be a wrong assumption. There are budget Gen 4 drives. So you might end up with a Gen 4 drive that costs a little more, but then it only runs just a little tiny bit faster. You do get what you pay for in this, in this industry. So, you might be thinking to yourself, wow, I scored a bargain, when in fact, it was a wash one way or the other in some cases. Now, I'm going to go ahead and put the CPU and the heatsink on next. We'll slap the RAM in it. We're just going to see if it boots. I'm hopeful it will not boot, that it will need the BIOS update. But these are live videos. They are unscripted. Everything is shot in one take. One of the advantages we have with the pandemic and the part shortages that we've been dealing with is there's not a lot of old inventory sitting on shelves. So the build Mitch and I did last Friday, that motherboard has been sitting around here for about 5 or 6 months. So I guarantee that one would need a BIOS update. This board I recently purchased, and it may have just been restocked from the place I purchased it from, Amazon, with the latest BIOS coming off the line of manufacturing. I don't know what the odds are. Only one way to know. Now, by now, I'm sure you've seen me install the Mugen 5 countless times before. The i5 CPU, this arrived while we were live on Friday, and it was shipped in a padded envelope instead of a box. Usually Amazon puts stuff in a box, and this was crushed pretty badly in that padded envelope. The good news is it's a CPU. It's very difficult to break a CPU. There's our instructions. The box goes into the trash anyway, so don't be worried if you get a damaged box like that with the CPU or any solid state, motherboard, RAM. It's likely not going to damage it. As you can see, we've got a 13, well, I better say it's a 13600K CPU there, and that is the latest 13th gen. I think that's what it says. 11 600K. Now, if this had an F on it, that would mean there's no built-in video, and we would have to provide our own graphics card. So you will see that the F versions of the chips are a little bit cheaper in most cases, because what they have essentially done is disable the onboard video on the die. It's not like they're making them any different, but there's no way for you to re-enable it. So be aware of what you're buying and know what to expect. I always like to have built-in video, even if I were going to put a discrete graphics card in it. It's good to have for diagnostic purposes if we're trying to figure out a problem later on. So let me go ahead and put this in. There's a little corner here that's cut out, so you can get a finger underneath that. You just lift that straight up. And then there's two cutouts on each side of this plastic, so you can reach your fingers in and take that out. Then here on the socket on 1700 is a little more robust than prior Intel sockets on the consumer side. So you'll see it kind of reminds me of a way a Corvette hood opens up the opposite way. I don't know if you've ever noticed that on a Corvette, but that's what it's reminiscent of. Of course, people always tell you about looking for the microscopic golden triangle. I'm going to simply tell you, look at the notches. Every Intel CPU in their core line have little teeny tiny notches. In this case, we've got 2 notches on this side and 2 notches on that side. And then if you look in the socket, you can see the little plastic notches here and here, and they're not exactly across from each other. They're offset. That way you can't put the CPU in 180 degrees backwards. I also know that the writing always faces down, top to bottom. If you could picture this in a tower case, then this would be the top, this will be the back of the case, and all the writing then flows top to bottom. And when we set this down, we want to just kind of find the edge, bring it down as far as you can bring it. Now you can see I'm pretty far off on that socket, but now just gently, without pushing down, all I want to do is slide this CPU and it starts to fall into what is a tiny ledge there. And we're hovering above 1700 little delicate pins underneath it. That's why we don't want to press down. And I've just noticed we've got we have a triangle etched into the heat shield. I don't know if you can see that right there. There's a pretty strong light reflection. Maybe I can tilt the motherboard. It is very difficult to see, but it is there, just in case you want that reassurance when you're installing the chip. Then we can lower this lid back down, and we're going to have a lot of resistance. And this lid, you can see, it's not even letting us get this down far enough, so we have to pull this off by hand. See the difference that made? Because we need this little metal, how this is bowed out. That's going to push down. Now it's going to put force across all 4 edges of the CPU. And you got to use a little strength here, push down, and then hook the latch underneath that catch. But it's critical, absolutely critical. You make sure this is in the socket straight before you attempt to put that much force in pushing it down, or you could bend the pins underneath. That would be user-caused damage, not covered by warranty, and you're out a $200 motherboard. So take your time, be patient, be certain that you are fully in the socket without pushing down on the chip to avoid damaging those small pins. This is a much better way to secure a CPU, in my opinion, than the old pin method that AMD was using. And thankfully AMD's let that go, because you try to take one of those CPUs off and you've got a heatsink on top of it, and you're prying that heatsink, and what happens? It pulls the whole CPU right out, and it can damage or even break off the pins on the bottom of the CPU. And there's not a whole lot you can do about it to prevent it. It's nerve-wracking. Using a socket like this, the CPU is locked in, and no matter how tightly a heatsink sits on top of it, we can get like a flat blade screwdriver, kind of get it under there and twist it, as long as we're on the frame here, and it'll break free that CPU heatsink without the CPU moving at all. The CPU is not going anywhere. So as a technician, much better design in my opinion. With that, I can put the heatsink on. And I'm just wondering, should I put, do I want to put the Mugen 5 on there? Yeah, heck, let's put the Mugen 5 on there. I like the Mugen 5. It's the black edition is a few dollars more. It's $65.99 at Amazon. It goes on super easy. You get a free screwdriver that's magnetized. It's going to make the installation even easier. We've got our cooling fan. We'll set there. And then, of course, we have the heatsink itself right here. Just pull that open such as that. And we'll just set this aside. Keep it out of your way. You don't want to damage it, but do keep your work area free of things you can knock over or knock into the board, just so that you'll be more likely to be successful and less frustrated when you're trying to work this all out. I don't know why it's so important to me to put this all back the way it was. It's all just going to go in the recycle bin. But I don't just watch the detail when I'm building computers. I watch the detail, for the most part, with everything I do. So when I'm emphasizing to you to watch the details on some of these specific things that are easy to screw up, like damaging that socket, I hope that you would always watch the detail across the entire build. Take your time, enjoy it. In this bag, with the Mugen 5, we have all the mounting necessary for all different kinds of AMD and Intel chips going back for years, years and years and years. As a result, because they don't know which chip you are going to need this for, it comes out of the box ready to go for an Intel Socket 1700 with this backplate. You will not use this backplate on any AMD or on any X series Intel chip. The X series chips are typically high-end workstation chips used in business. So if you're following along, you've got a Socket 1700 board, this is ready to just plug and play, just slide it in. You'll see there's holes and cutouts so that even if we reverse this the other, turn it around this way, it doesn't make a difference. It fits exactly the same, so you cannot get it wrong. And we're going to set that down. And you'll see I'm working on top of the motherboard box. That's because this is a non-conductive, cardboard is non-conductive, and I don't want to scratch up my workstation, you know, my Lazy Susan or my desk. The bottom of the board has got pointy solder points all over it, and they'll actually cut right into your hands. So you'll notice I handle all parts by the edges, or, you know, I'll grab it by a heatsink, or I'll grab it here by this heatsink, because I don't want to cut myself, and it's also a very easy way to dissipate electrostatic discharge. Since I would only dissipate an electrostatic discharge through the heat sinks, I don't have to wear a grounding strap because it wouldn't cause any damage to anything. In this bag right here, there's a bunch of stuff in here we're not going to need. So I'll start out with these long screws. These are for use on AMD chips. So we're not using AMD chips today. So those are not going to be used by us today. These little standoffs, these are for Intel X series chips. We're not doing that today. And all that leaves us with our 4 thumb screws and 4 plastic spacers. The 4 plastic spacers, one side is rubberized and one side is hard plastic. Hard plastic side goes up, rubberized side goes down to cushion against the top of your motherboard. There is some resistance when we push down. That's good. If you put it on there and it just slides on, it's upside down. It should immediately have resistance. That's also going to hold that back plate in for us. So if I were to pick this motherboard up right now, it's not falling out anymore. It's one thing when you've got another person helping you who can hold the back plate in for you, or you can set the board on something to hold the back plate up. Nothing's better than that, in my opinion. In this bag right here, we've got a number of brackets. Once again, there's different brackets for different CPU types. These giant brackets that look like parentheses, that's for an AMD build. We're not doing AMD. These straight brackets that have a bunch of holes in them, that's for all the other Intel consumer chips like 1150, 1151, 1155, 1156. And then finally, these brackets that look awfully similar, but they have a lot fewer holes, that is our socket 1700 brackets. And they're going to go in the same direction. They do not go this way. You see that lever right there? They're going to go over the lever. And you see how that's lifted right there? It's lifted to get over these capacitors so it doesn't squish them. I'm going to take the exact matching one and put it on just like it's a mirror. They face each other. And then we're going to grab the thumb screws and we're just going to tighten those down. I recommend starting these by hand. And then we can use the enclosed Scythe screwdriver to tighten them up. But look how easy that is to put on. I don't know why anybody would choose a different air cooler at the $65 price point. I'm not aware of a cooler that cools as effectively as this cooler does, that has a heatsink the size that it is, that's as easy to install as it is at a $65 price point. It just doesn't make any sense to me why you would spend $65 on a different air cooler, because they can only be more difficult to install. None of them will be as easy as this. And if you know of one that is this easy, you let me know, because as far as I can tell, none of them are that easy unless they're a smaller heatsink and they're still at that $65 price point. I think this is unmatched in value. I am not paid by Scythe. I don't even think they know who I am, but I've been using the heck out of these coolers, and many of you have written into me to say that you've utilized them and you love it. Some people have written in and said they got rid of their liquid cooler and replaced it with one of these, and they're not going back to the liquid cooler. Clearly not the best overclocking cooler. But if you saw Friday's video, we were cooling a 12900K, and the thing never got over 80 degrees Celsius after 20 minutes of prime 95, which I was not expecting that result. That's really surprising that the cooler works that well. And also that Intel's doing such a good job of keeping that chip cool. Because what I read online, they had me believing that chip was going to be hard to cool. So I don't know what they're doing differently than me, but you can go back and watch that video if you missed it on Friday. Based on what I read online, I was prepared to have a heat-related issue, and I was just kind of curious how long it was going to take to happen. It never happened. So that's a 12900K being cooled just fine on the $65 Mugen 5 that's this easy to install. Now I'm kind of curious about the 13900K. Can the Mugen 5 cool it? Right now the 13900K is about $160 more than a 12900K. 12900K, you can pick those up about $500 right now in late October of 2022 here in the US. And I saw Amazon had the 13900K for $740, which is messed up. That's got to be a third-party seller gouging. But if you go to B&H Photo or Newegg, you should see it around $650, right in that range. That $150 difference between a 12900K and a 13900K, with everything else being the same, you're not getting $150 worth of benefit out of that. So I'm reluctant to spend that kind of money for just a 10% increase, but I really want to know if the Mugen 5 can cool it. I'm just surprised that the Mugen 5 cools the 12900K as well as it does. And now, I wasn't expecting that. So now I'm like, well, would it do the same on a 13900K? So once again, for me to conduct that experiment, there's another $200 motherboard, there's a $650 processor, RAM, solid state drive. We're looking at almost $1,000 just to do the test. And then I have to figure out what to do with it when I'm done. And that's the only thing holding me back. If you're wondering why I haven't done certain videos, in most cases, it's because the funding isn't there that I can afford to do it. You'd be surprised the amount of content that I have been able to make that I didn't think I would be able to make as quickly, one after the other, given that almost every video contains different parts. And unless it's customers provided parts, you know, or I have to sell my soul to the corporation and be their spokes puppet, and then they give me the parts for free as long as I say what I do it the way they tell me to release the video on the day they tell me to release it, and I say everything that they want me to say and nothing that they don't want me to say. I don't think it's worth it for me to sacrifice my integrity for. I don't want to hold back or omit information from you, my viewers, no differently than I wouldn't want to hold back or omit information from my customers in my real business. And if you were a customer, I don't think you'd want any business you deal with holding back or omitting information, I would think. But if a company's paying for you to make their content, you better make it the way they want it, because that's what they're paying you for. Now, we have a small tube of thermal compound here, which I will apply. I just kind of eyeball a little dab of it here. There's a lot of debate and argument over how thermal compound should be applied. You should apply it however you want to, whatever makes you comfortable. When I build computers, I have to support them. It's not like it's just going to go in my bedroom, and if there's a problem, only I deal with it. These are being sold quite often to customers. This one isn't, but it hopefully will be. And if there was a heating or a cooling issue with it, I'm the one who's going to get the call. So I want you to understand what my motivation is. Like, I don't really care how you want to apply your thermal compound, but I'm also not going to argue with people. The actual thermal material itself doesn't much matter in reality. Whether you want to spend a whole ton of money for what is considered to be a superior thermal compound, or just use what's included for free, if you actually run your own test and try applying the thermal compound in different ways and use different thermal compounds, you will see the truth. The truth is out there in the internet, but it's very difficult to spot it. It's just, the truth is mixed in with people's emotional feelings. And so the only way you can be certain of what the truth is, if you're curious, is to run the test yourself. At most, thermal compound and how you apply it makes about a 3-degree difference in temps for most people. And you have to allow for the temperature room change. It just changes throughout the day. You have to allow for a 3-degree variance at least, meaning any difference would be subject to room conditions and negligible, not enough to say that there's absolutely a difference. XRod666 contributes $5. He says, hey, Carrie, what all-in-one cooler do you recommend for a 3900X? I got a Scythe Mugen 5, and it's not cooling it very well. The 3900X from AMD and 3950X are pretty hot chips. I'm using a liquid cooler. What am I using? So remember Marvin, he brought that system in and he had that liquid cooler that was junk. We took that liquid cooler, threw it away. And Marvin's old system, which was a 3900 or 3950X, is now sitting in a system right over there. I don't know if you want to turn the camera, people can see straight down there. Yeah, and I just haven't gotten back to it, but we have the liquid cooler on there. And I think really any name brand manufacturer, oh, you just disconnected us. There's a, there we go, now we're back on. The, any name brand manufacturer, NZXT, Corsair, ASUS, I stay away from Manufacturers I haven't mentioned. I was on the fence of whether or not to mention names, but generally speaking, stick with a name brand manufacturer. And it really shouldn't matter who the manufacturer is. If it's a 240 millimeter cooler or a 280 millimeter cooler, they should all pretty much work the same and have the same or similar warranty, whether or not you want RGB or you want, USB ability to control the pump. That's going to impact the price. And the big manufacturers offer them in many different sizes with and without RGB. RGB does add significant cost, but at the end of the day, I would be putting on a 2-fan radiator. In other words, a 240 or a 280, assuming your case can accommodate for that. If the Mugen 5 isn't working and you absolutely want to stick with an air cooler, the Noctua DH15 can't be beat. If I ship a computer with a Noctua DH15, it always arrives bent in half. It's heavy. And if you want to see your motherboard, you won't see it. All you're going to see is a giant heatsink. You could also try adding another fan onto the other side of your Mugen 5 if you haven't done that. So you have an intake fan and an output fan, both moving in the same direction, moving the airflow out. Depends just how much heat you're trying to stave off there. And you could try removing the heatsink, wipe off your thermal compound, reapply it again. Use my method. Try using a nitrile powder-free, non-sterile glove, finger paint that on, and be a little more generous with it. If you're too stingy with your thermal compound, it may not effectively be pulling the heat off. So don't put so much that it's going to ooze, but maybe you haven't put quite enough on, maybe just adding a little bit more. If you close in on that, you can see the little peaks and valleys. And I'm on the fence of whether or not I should be putting a little bit more on there, but I think it'll be fine because it's an i5. If this were an i9, I probably would put just a little bit more, especially it's a little thin around the edges there. The majority of our heat's coming mostly from within those edges, but it does spread out. So it's really something you have to gauge it yourself. But too little thermal compound is worse than too much in most cases. Okay, now I can put the heatsink on. So we have to remove this little plastic cover right here. Once again, we want these, anytime we're transferring heat and we're using a material here to help in that transition, we want to make sure we're getting the best thermal transfer possible by making sure the surfaces are completely clean. Dust, debris, oils from your skin, all of that. One side of this heatsink, you'll see the screw sticks out. The other side of the heatsink, the screw is underneath. Where the screw sticks out, that goes towards your RAM. I'm going to set it in just like this. And we're using the enclosed screwdriver from Mugen. You just want to get one screw started. And then I want to get the other side started here. If you tighten one side too much, it puts a whole lot of tension on the opposite side, and then you have to push down really hard to get it started. So once we start them, we're going to go back and forth and try and tighten them up evenly. We don't want to tighten one side by itself. We want to keep going back and forth so that we have complete level contact across the entire surface of the CPU and the entire bottom of the heatsink. That one's come to a dead stop, so we don't turn it any further than that.
25%.
What are you at?
25%.
25%. All right, well, that's good. We're just about ready. I guess 25% of the battery is all that remains on our close-up camera. I'm going to quickly slap this fan on. I've discussed this numerous times, so I'm going to just get on with it. And thank you for the contribution, X-Rod. And thank you for your question. Okay, there's one side. other side. Bring this down as far as it'll go. It hits that screw. And then just center it. Pull back on these little wire hangers. And they go into the grooves of the heatsink. And I do need to wire tie this, but just to get on with things, or zip tie, just to keep things moving now, I want to put the RAM in. Now I've got this RAM laying around here, whatever this is. It's 8 gig PC4 19200. Ugh. All right, now it's fine for now. I definitely won't be leaving this RAM in here. It'll be a total of 16 gigs, which I consider to be minimum for Windows 10 or Windows 11. If you have anything less than 16 gigs of RAM on your desktop or laptop running Windows 10 or Windows 11, you will see likely an improvement of performance by doubling that. Now, you'll see I'm using the metal reinforced socket only. The RAM only goes in one direction. I always make sure it fits into the track easily without force or frustration. Then I can use my thumbs, push down one corner, then the other corner, and that locks the RAM. That's 16 gigs of RAM, 2 terabytes of storage, our new i5 13th gen, our Scythe cooler, all on our Z690 sesame seed bun. All right. You ready for a test? All right, I think we'll go ahead and give the camera a break. We'll go back to our main camera here. Boom, here we go. You're free and clear. Thank you.
You're welcome.
All right, now, let me just look here in the chat, see if I missed anything. Elijah says, hello, Carrie from DC. Joseph Winterhalter saying hello from Aurora, Colorado. Patrick says maybe they tape the motherboard bag because it has to travel through the warehouse to the boxing station. But nobody else does that. Like ASRock and MSI, I don't think, ASUS, I don't think they do that. So I don't know why that would be different. But yeah, that's possible. I don't know. I just think it's odd. Ronald Robertson says, I love your stuff and the way you present it, but I'm not going to be a member. I will still watch your stuff, but seeing as you can't help me build my PC, I might as well be a fan. You know, it would be very difficult for me to help you build your PC. And, you know, look, if you could get someone to give you personal hands-on tutoring for $10 a month, boy, I'll tell you, that'd be a good deal for you, though I don't know that it's a sustainable process for the other person. And I do appreciate that you are a supporter. And if that's not working out for you, if you don't feel you're getting your money's worth out of that, by all means, you know, you do what you have to do. And I try to give people as much personal attention as it's humanly possible. I'm averaging about 10,000 views per day. So as you can imagine, in a month's time, that's what, 300,000 views. Some of those, probably 70% or more, are first-time viewers. They may never come back again. I don't know. They might decide they like what they see and become a subscriber. They might become a supporter. Unfortunately, I can't meet everybody's set expectations, but what I do attempt to do is not mislead people into thinking I ever offered that to begin with. So that if someone comes up with this idea of expectation that I never offered, I certainly understand why it may not, you know, it may be disappointing, right, for you that you didn't meet your expectations. I try my best to always set expectations, not to make decisions for you, but to just let you know, if you choose this, expect these consequences. And if you choose that, expect these consequences. Expect these benefits on this side and these benefits on that side so that you can make an informed decision that's right for you. Once again, I want to teach a man to fish. I don't want to feed a man a fish. So I encourage you to build your own system. I have enough videos here on YouTube that it should eventually become so repetitive that you don't want to watch them anymore Because if you go all the way back to 2008, I'm still doing exactly the same thing. And I am mostly, apart from some parts evolutions like the CPU socket or DDR3 to DDR4, or going from a mechanical drive to a solid state drive to an NVMe drive, the concepts are all basically the same, in much the same way that an engine built in 1940 isn't really all that different from an engine built today, minus some electronics. The fuel delivery system is a little different, but the engine itself and the what we're setting out to accomplish hasn't changed. Internal engine combustion theory is the same today. We've made it more efficient. But if you knew how to work on an engine in 1948, you likely know how to work on an engine today. So again, I appreciate the support, and do understand that it's because of the support the videos you're watching are available. All you have to do is look back at this channel prior to when it started to get monetized. And you'll see in 2008, 2009, 2010, 2011, very few videos posted, maybe one a month, maybe. In 2008, maybe 2 videos. Well, the videos could only be 15 minutes in length, so to do a computer build would take about 90 minutes. Break that up into 15-minute pieces, but to me it's one video. And then do an Intel build, do an AMD build. That's all I did in 2008. And in 2009, there were a couple more. In 2010, a couple more. And then I reached a point where I didn't have the time or the money to do any more than that. With the support, not YouTube monetization. YouTube monetization is painful. I have 100,000 subscribers more than I had a year ago just to make the same amount of money from YouTube monetization. So just to stay flat, I have to keep increasing my volume. If I don't, then if I'm still producing the same amount of content as I was last year and I'm not growing viewers, then I'll be making a good 66% of what I was making. It's a good third. Anyway, I'm not complaining about it. I'm letting you know what my challenges are and what prevents me from providing more content. And if people want to support that, that's great. And if people want to watch what I do for free, that's great too. It's there for the benefit of everybody. And I would love the opportunity to have a full-time schedule Monday through Friday to make videos. There's no way that will cost at the end of the month. It'll cost somewhere around, I'm going to estimate $25,000 to $35,000, and may generate maybe $3,000 of revenue. So you can see that's not a sustainable business model. But I have to figure this out to be able to make videos that are less expensive to make, and to be able to generate enough revenue that I can make more videos. I have no shortage of content. I could make videos every day for this year and next year, every single day. I would never run out of ideas, at least for a year, at least. But I will run out of money very quickly. So if you are ever seeing a time when the videos aren't coming out as often, or I'm not doing as many reviews of products, it's because the money isn't there to support it. That's all it is. So just trying to set your expectations so you know what to expect and why that happens. It's not a punishment. I'm not trying to goad people into contributing, but I am trying to have you adjust your expectations for what you should expect based on what the challenges are. So with that, I do hope you build your computer and enjoy your build. And I hope it lasts a really good long time, and it is the best computer you'll ever own. And likely you'll want to build another one, and you'll start understanding the money problems real quick. It gets expensive. Now, again, I'm expecting this not to boot up, not to post. Well, here's what I expect to happen. When I put the power supply on this and I hook up my power switch, I expect to see the light come on the motherboard. There's probably some diagnostic light. I expect to see this fan up here on the heatsink begin to spin. And then I expect no video to come out. If we get video, that means that we don't have to go through the BIOS flashback process. I'm going to grab my power supply. This is just a 500 watt EVGA power supply. Last Friday's show, I set this power supply down, and I told you guys, don't do that. I've said it so much, I don't even think about it anymore. See, the fan on the bottom of this power supply, it's actually drawing air in to the power supply. It's not blowing air out, it's drawing air in. Then that air comes out the back here. So when you hear people talking about how hot their cases are, or how their thermal temperatures of their CPU or their video card are, you know, by adding more fans, or they're going to these extravagant efforts, the power supply isn't being monitored for temps, and the power supply isn't affected by the heat of your system. The idea is that it's going to bring air in from the outside and then bring it into the power supply and then blow it out the back of the power supply. It never enters the computer. And so you could have a power supply that's overheating, that's not cooling well, that's suffocated because I had the fan down, so it's having a hard time breathing. If you put your computer tower on carpeting, you want to make sure that you have a little space above the carpet for the air to get up under there. It's so often ignored, it's maddening that people act as though they're so intelligent by how they've masterfully cooled their CPU or their graphics card, and never, ever mention their power supply. So I guess if you don't talk about it, it's not a problem. So I give you this information because I don't want you to be like them, and I want you to notice it when you see it. All right, so now I'm just going to put the big 24-pin power connector onto motherboard, and probably need glasses. One of the frustrations I think many beginners are going to find is that everything's black. So it's black on black, and it can be very difficult to see details black on black. If I wrote you a letter in black ink on a black piece of paper, you probably have a hard time reading that letter. So this is what happens with electronics. A lot of times is people can't see it very well. And I'm standing right in front of it, and I'm sure the camera is probably even difficult for you to pick up the space between these two, you know, the plug and the socket, and I'm going to kind of wiggle and push down, and that little clip is going to lock it in. Then right up here, we have two more connectors. We only need to use the larger of the two. The secondary one is for additional voltage when or if you're overclocking. I think overclocking is dead. I think it's been dead for some time. What you have to spend and the trouble you have to go through for what little tiny gains you're going to get, and only temporarily, because in another 8 months there's going to be a newer CPU out that'll likely run that fast without any special cooling or difficulty in configuring the BIOS to find where it's, you know, how far you can push it before it breaks. So I'm not going to use that secondary smaller connector. Now, if I hook it up anyway, if my motherboard had it, which if my power supply had a secondary motherboard connector, which it does not, and I hooked it up, it doesn't cause me any harm to have it hooked up, even if I'm not overclocking, but nor does it do me any good, and it's one more cable I have to manage. So that comes along with this hobbyist activity, which mostly hobbyist activity, of trying to eke out, you know, 7%, maybe 10% more performance, which is nothing. When we initially overclocked back in the day, you could take a processor and double or potentially triple its speed. When you can take a Celeron 300 socket, a slot A processor, and you could overclock that slot A processor to 900 megahertz, you made it 3 times faster. Worth it. 300% improvement? 10% improvement? Meh. Meh. You'll get that generation to generation. Just wait for the next chip in a few months if that's important to you. Let's see, I need a power button. Power button. I'll use this little dealy bopper. I buy these little power buttons off Amazon. This one has a little power switch, a little reset switch, a little power LED, a little hard drive LED. And then what I did is I took one of those G connectors, which similar to what was included in this motherboard box, and I drill out the little holes on the bottom that are blocked so it'll work on other manufacturers' motherboards. And this way, the power switch, the reset switch, the power LED, and the hard drive LED, They always go in the same location on all ATX and micro ATX motherboards, regardless of the manufacturer, unless it's a pre-built or if it's a mini ITX. So all I have to do is take this connector, and with the cables going to the left, just seat it down, and then I don't have to mess with the 4 pairs of cables, positive and negative and all that. It's already done. And finally, I just need to give it power, keyboard, mouse, no internet, and video output so we can get it onto the capture card and see what happens. All right, so power, make sure the switch is off on the power supply. We'll plug that in right there. Keyboard and mouse I have right over here. So this is my wireless keyboard and mouse. They have rechargeable batteries that are sealed. So I just plug this into a USB port to charge them up. They last, with as infrequently as I really use these, 3 or 4, sometimes 5 months between when I have to charge them. But there's no actual battery that you replace. It's all sealed, like a cell phone, modern day smartphone. They have a little power switch. I turn them off to save the battery, but they do auto power off on their own anyway. That's just my OCD. I might be getting a few extra days of life by turning it off manually. It just makes me feel better. All right, so there's a wireless dongle. Because these 2 wireless devices are paired together, I don't have a separate dongle for the mouse and a separate dongle for the keyboard. All I have to do is plug one in, and that connects both our keyboard and mouse. And then finally, the HDMI cable. And that's going to go to our capture card so you guys can see the direct output of this motherboard. That's it. No internet, no flash drives, no unneeded materials or peripherals are plugged in, like RGB lighting and stuff like that. If it's, you know, something that can be unplugged, leave it for right now, because we want to make sure that this works. If we put a bunch of other stuff on there, we don't know if it's the other stuff that's causing this not to work. So we need to make sure with the bare minimums that are required that that operates. So let's see. It's getting exciting. Put the switch to on the power supply. Leave the power supply vertical so the fan can breathe. And I will take one more look in the chat here before we start. XRod666 says, Carrie, thank you again for the Windows 10 product key. I don't know of any other YouTube channels that would do that. Once again, for those of you that don't know what he's referring to, that's XRod666 in the chat. I've told, and just in case you missed it, if you're a member of my channel, it's $9.99 a month. And you say, okay, well, what am I going to get for that? Well, apart from the ability of me creating more content, which benefits everybody, regardless if they contribute or not. If you've been a contributor for 3 months, a supporter of this channel, that means you've spent $9.99 in 3 months in a row. That's $30. Now YouTube's going to take 30% of that right off the bat. Government takes about 30% of what's remaining. It's about 50% is what I get. So I'm going to pocket $15. What I will do for you, if you want a Windows 10 product key, Windows 10 Pro product key, I will purchase one for you and send it to you from our good friends at VIP CDK Deals. I actually buy it. VIP CDK Deals is not giving them to me. I will buy it and I will send it to you. Now, I'm not going to make any money, but I hope it builds goodwill and loyalty. If you say, I don't need a Windows 10 product key, okay, well, look at how much Microsoft Office costs over at VIP CDK Deals with my discount code, Carrie. If you've contributed that much in membership, so in other words, if you've been paying $9.99 a month for 6 months, you've spent $60, right? YouTube, let's just cut it in half. When we subtract YouTube's fees and we subtract the taxes, cut that in half, I will pocket, let's say $30. I can buy an Office 2016 product key for under $30 and send that to you. instead of the Windows 10 key. Or if you've been a member for 9 months, right? And so you've been paying $9.99 for 9 months. You say, all right, after 3 months, I want my free Windows 10 key. And then 6 months after that, you want an Office 2016 key, and assuming they're still available, fine with me. Or after 3 more months, you say, I want another product key. So it's all based on how much you're contributing to how much you can expect back, but you have to email me and ask me for it. And I need to confirm your name and look at your membership history to make sure I'm not being swindled. And of course, I do absolutely expect you to use the product key quickly. The reason is I have a million things going on. And once you go beyond 30 days, getting any support, if there are any problems, you're not going to get any support. Same is true if you buy something at the store and you come back after 30 days wanting to return it. You know, Amazon is an exception, but places like Best Buy or heck, wherever you shop, generally have a 30-day return policy. So please don't ask me for keys that you're not going to use for a long time and then email me back after a certain period of time, you know, after let's say 2 or 3 weeks, and the key's not working. You know, at 2 or 3 weeks, we still have time, but I'd rather not stress me out with that. When you intend to use the key, if you've built up that credit with me, just send me an email that you're ready for the key. I'll purchase it and I'll send it to you. And then if you have any problem, well, it's still fresh on my mind. I know who you are and what we just did. I don't have to go back and research who you are. With 10,000 new viewers every day, things are crazy and everybody thinks they know me, right? Because you're watching me. Very few people think they take a minute to introduce themselves to me before they engage in conversation. So do keep that in mind. That, you know, don't take it personally if I don't remember who you are. You should assume I don't remember who you are unless we have established a much closer relationship, which I have with some of you. Most YouTube content creators that I know at this scale and higher simply don't even respond to emails and things because it's very, very time consuming. But I'm, you know, even as the channel grows, I'm still making sure that I'm communicating with the people who are supporting me. That's critical to me. And then if time is available for me to answer other people's questions who, you know, just randos online, I certainly don't have any problem with it. It's just time. So yeah, nothing personal. But yeah, XRod666 had hit me up and said, hey, were you serious? He'd send me a Windows 10 product key if I've been a member for 3 months? I said, yeah. He said, well, I've been a member for like 5 or 6 months. Would you send me the key? I said, are you ready to use the key? He said, yeah. I went online, I purchased the key. I sent it to him. He confirmed it worked. I always love getting those confirmations so I don't have to worry. And we're good. So it's real, folks. It's real. It's just a way for me to show my appreciation, to go above and beyond for the people who go above and beyond for me. So here we go. We're going to fire this thing up and see if it boots. I'm hopeful, as odd as this sounds, that this does not boot. Or post, is what we mean to say. Power on self-test. So let me turn on HDMI input 1, and let me get my camera a little smaller so we can both see together what's about to happen. Okay, you guys, you think it's going to work? Here we go. I don't know which of the two buttons is the power button. One's a reset button, one's a power button. Apparently this button on the left. Okay, as predicted, fan is spinning. There's an LED on the motherboard. Everything so far is exactly what I expected. Now, the question is, will we get the power on self-test? Will we see the GIGABYTE logo? I hope not. The reason we're not going to see it, if we don't see it, is it doesn't recognize this chip. It says, hey, this isn't a 12th gen chip. I don't know what it is, but it's not a 12th gen chip. Only through a BIOS update can we give it tell it how to recognize a 13th gen chip. Now, it can take up to 90 seconds for your first boot to occur. So because it hasn't happened yet, it still could. So we want to make sure to give that a full 90 seconds. I'm seeing the light blinking here. There's a little diagnostic LED doing something. And I'm going to just bide my time here for about a minute. Give it every opportunity, every benefit of the doubt to boot. Because I want to know for sure if I'm fixing it or not. So we have to absolutely be certain it's not working before we can know if we can fix it. And so far, it's looking pretty good. This is what I was hoping for. Now, the whole system just shut off and has started back up again. Well, that's interesting. Normally, it does that after it trains the memory, and it says, okay, now that I see what memory you've got and I see what chip you've got, I'll make those changes to the BIOS and reboot the system. Sometimes, however, when it's trying to boot and it times out, it starts again, it resets itself and starts again. So in other words, it's not frozen. It's just saying something's not right, let me reset. So it literally just reset itself, and likely this will continue. I'm seeing the diagnostic LED on the board moving. It's got a couple of segments on it. It's just moved again. So we know the board is trying. It's not frozen. And it certainly should have given us something by now. I just want to wait and see if the system resets, if the fan on the CPU heatsink stops again, because that would indicate a reset is happening. I'm seeing that red LED diagnostic move around. Like I say, there's about 3 or 4 of them here. I don't know what it's telling me, nor do I care. I fixed computers before there were such diagnostic tools. And for the most part, repairs are the same diagnostic process. There, the machine just shut off again, and it's reset again. I am really convinced this is exactly what I was hoping for, that it just doesn't recognize that chip. Now, we can't just use any chip. We can't put anything other than a 12th or a 13th generation Intel chip on this board and expect it to work. So I don't want to have you misled in any way that you could just take an older chip or, whatever to make it work. It's got to be compatible with the socket. So the socket 1700 is strictly Intel 12th and 13th generation only. Likely 14th generation will yet again be another socket. That's how we keep advancing and moving forward. So what I'm going to do, since we're not booting, and this is exactly what I was hoping for, so I'm going to cut power off at the power supply. Now I have a bootable, I have a blank USB flash drive here. Let me go full screen on camera 1. There it is, right there. This is a blank 2 gig, a very tiny little flash drive with regular FAT format, file allocation table, FAT. No NTFS, no exFAT. And I'm going to plug it right here into my streaming computer. You will need another computer. Borrow a friend's computer, whatever you got to do so that you can acquire the BIOS. It does require a working computer to do what I'm about to do. Now, what I'll do is I'm going to open another tab. And, or you know what, let's just use, just so I don't confuse myself, I'll open Microsoft Edge, since this is the computer we're live streaming from. And then I can share the screen so you guys can see what I'm seeing right here off of this computer. So that'll be turning on window capture in OBS for Microsoft Edge. And we'll turn that on and turn camera 1 off. Okay, good. Make sure that I am full screen, yep. Now, I go over to this screen, and in Google search, I'm going to type in the name of the board. It's a Z690, AORUS Elite AX DDR4, enter. I like Google because usually the first recommendation is the page I want. So Z690, AORUS Elite, and GIGABYTE.com, that's where I wanted to go. We'll click that to bring up the product page at GIGABYTE's website for this motherboard. And we'll go over here to support. Not the support up here, that's generic support. This is support specific to the product page that you're on. And every motherboard manufacturer does this. ASUS, ASRock, MSI, GIGABYTE, all the big manufacturers have a support up here and a support link on the product page itself. So that's why I'm selecting that support. And then we're going to go to downloads already here. We're going to scroll to BIOSes. You'll see there have been 7 BIOS releases, with the latest one being F8 that came out in August. Hopefully, that's going to add 13th gen support. It says include support for the 12900KS. Uh-oh. Well, I'm going to go ahead and hit the download button on that. And while it's downloading, I'm going to go up here to CPU support and see if the 13th gen CPUs are even in here. Likely you would have done this before you purchased the board. So we're seeing support on 13900. Oh, and that's, they didn't group all the 13s together. So what do we have? A 13600K. Yeah, it's in the list, and we need, probably tells us what BIOS we have to have. This is saying F20. Since BIOS version F20. I didn't recall seeing a BIOS version F20. Look again. Am I missing something? F8, F7. Well, I'm a little concerned about the age of that, because the 13th gen chips weren't released in August. Where does one find F20? I wonder if it's, let me go back to the CPU support. Socket 1700. Then it says since BIOS version. You know, there's not even an F8 listed here. So I wonder, Z690 AORUS Elite AX DDR4. That is our board. Why is the BIOS version not aligning? I don't know. Very interesting. So what I'm going to do is I'm going to bring up the file I just downloaded. You guys probably won't be able to see this part of it. And I want to extract its contents and take a look at the README document inside of it to see if it talks about how to do the BIOS flashback, or I'll have to find another support area to explore that. So let's see, that is BIOS version F8. I see there's a ATI flash PDF file. BIOS flash SOP, standard operating procedure. Download the BIOS. Use the USB flash drive to boot the system into EFI mode. Okay, the system doesn't boot. So do we have instructions? For flashback? Not there. And then that's all EFI. Well, so this is what I like about doing this live, is there's information here that we need to find. They've not made it easy. So let me go back to camera 1. There we go. And let me search around a little bit to see what I'm missing. Times like this, we can always go to Google, cheat a little bit, because we didn't have this option in the 90s. At least not in the early 90s or mid 90s. Let's type in how to flash Z690 gigabyte. What's the word I want? With ASUS, they call it flashback. I'll just type 13th gen. Need help for BIOS flash. Yeah, that's the first link. There's a separate section for the different BIOS directly below all of the different drivers, the latest of which is from October 7th. The latest one is necessary to support 13th gen. A different section for the BIOS files. Oh yeah, well that's where we were looking. That is, it says BIOS. It shows all the BIOSes. But it doesn't tell us how to flash it when the CPU isn't recognized. How to flash without CPU. Maybe that will pull up the documentation I'm looking for. Steps to updating the BIOS without a CPU. Go to your motherboard drivers page, download the latest BIOS, extract the download and rename the BIOS. Format a USB flash drive as FAT32, probably FAT16, or just FAT. These are generic instructions from buildgamingcomputers.com, and it says it's applying to all manufacturers. On Gigabyte motherboards, the feature is named QFlash Plus, not to be confused with QFlash, which is for updating the firmware from within the BIOS itself. On ASUS boards, it's called USB BIOS Flashback. On MSI boards, the flash the BIOS this way is referred to as Flash BIOS button, not to be confused with M-Flash. And on ASRock boards, it's specifically referred to as BIOS Flashback button. So you see, they all follow the same, more or less, procedure, but they give it different names, and the procedure's got some minor little steps that are different. Steps to updating the BIOS without a CPU. So let's say we download the latest BIOS update, which we've done. We need to extract and rename the BIOS. For Gigabyte motherboards, the file has to be renamed to gigabyte.bin. Have a clean FAT32 formatted flash drive, or FAT, regular FAT should be fine. Hook up your power supply, insert the USB drive, and push the Flash BIOS button. So, is there a Flash BIOS button on the back of this board? Let me take another look. Could be a button on the board itself. It varies from manufacturer to manufacturer. I don't see any buttons back here. I see QFlash Plus with a surface mounted button right there. So here's what we'll do. We extract the files that we just downloaded into their own folder here on the streaming computer. So I'll just type, let's see. Did I extract them already? Looks like I've extracted them. I'm going to copy the BIOS file. So the BIOS file ends with .f8, you know, the version of the BIOS. And I'm going to copy that .f8 file over to my flash drive here, which is already just formatted with plain FAT. I'm going to click once on it, and then it makes it so I can rename it. And I'll type in Gigabyte, and sometimes punctuation matters, but I don't think it does in this instance. Gigabyte.bin, and push enter. It says, hey, you're changing the file name extension. And I'm like, yeah. So I click yes to approve that. And then I can eject the flash drive from the streaming computer. So now this should have the right BIOS for this board with the right name. Plug it in. Let's see. Try and get you a close-up of this. I'm going to plug this in to the USB port, the red one here on the bottom. Okay. A little nerve-wracking. Let me get the close-up camera out. And we will switch over to... Oh, are you going to hold the camera for me? All right. Camera 3. There we go. So here's what I wanted to show everybody. We've got the flash drive now plugged into this very specific USB port here. Now, we need to hit the power switch on this power supply. We'll flip this back to on. Now, if you look closely right here, you see the writing, it says Q Flash Plus. So we're going to hold this button down, and you'll see this light just came on? And you'll see the BIOS, the flash drive is flashing. Now, this will take longer to flash the BIOS this way. So when we flash the BIOS through Windows or when we're in the BIOS itself, it takes maybe 3 minutes. If you look, you'll see also a flashing light next to the button that I pressed. And that's telling us that it's doing its thing. And of course, if we're curious what's going on, once again, assuming you have a flash drive with an LED on it so you can see read or write activity, one of the benefits of the older flash drives is that was pretty standard back in the day. These days, it's pretty rare to find that anymore. But that's what that LED is flashing. And it's just telling you, I'm working right now. Leave me alone. Don't mess with the keyboard or the mouse. Don't play with the system. It's doing something very important, and interrupting this process has the potential to make a situation where you have to send the motherboard back. So we'll keep watching this area right here, and we should get some indication when it's done. And I do expect this to take 3 to 4 times longer than a normal BIOS flash. Oh, now look at that. It slows down. But a flash drive is still blinking on and off, so it's still reading or writing. I'm sure somewhere in some documentation it tells us what the fast blink it means versus the slow blink, but that's the only indication of communication the board has with you to let you know it is working. So far, everything, as far as I can tell, looks very familiar to other BIOS flashback procedures. And I'm confused why the CPU support said since BIOS version F20, since we only have version F8. And the only 2 BIOS versions that it listed was F4 and F20 in the support side of things. So I don't know if Gigabyte dropped the ball there, but we're going to find out here in just a minute. Don't worry if you think this is taking a long time. It absolutely takes longer to flash a BIOS this way. That is universal across the board of all manufacturers. This is a slower process. So patience is key. It could take, boy, there was one system, I think we went just shy of 10 minutes. Now, I've never done a Z690 before like this, so I have no idea. I'm learning it just as you are. Still blinking, very good. Flash drive is also still blinking on and off. I don't know how well the camera's picking that up, but you can kind of see it there. My main focus is on this LED right here. That's what I'm really watching. And I would imagine when it's done, the system will reset itself. And I imagine that light will just go completely off. This amber light over here, down by the button. I don't know if you can tilt the camera and put it straight over that button. There you go. And you can really see that LED blinking now. That's where our focus needs to be, so we have an idea of what's happening. Without a screen telling us anything, this is how the computer is communicating with us right now. It's a nail biter, isn't it? Once again, the flash drive is still blinking on and off. The data transfer is going to be slow. The BIOS contains a lot of data in it. We sort of take for advantage, or take for granted rather, just how much data we're moving on a regular basis with all our drivers and NVMe drives and whatnot. So when we go back to something really old school and basic like this, it's old school for me, it's memories for me, but for you, this may be novel. This may be something completely new. I'm here to tell you, this is normal. Nothing's wrong yet. Patrick says, is that Morse code? Well, no, it's not Morse code. It's just basically saying, I'm not dead. You will be soon, you're very ill. I'm feeling better. No, it's just letting you know it's breathing, okay? Every time that light blinks, think of it as the system breathing. And it's recuperating. It's trying to recover. That's the best metaphor I can make for it. And that is our indication that it is in process. Flash drive is also still blinking. Having that light on the flash drive is, you know, for somebody like me that likes to know what's going on at all times, really important for me to see that. Now, it does say that you can do this without a CPU. We clearly have a CPU in there. But it shouldn't impact it one way or the other. There's no power light on my little external power switch over here because we never powered the board on. What we did is we hit the BIOS flashback button, or the BIOS, what do they call that? The QFlash Plus button, which brought power to the board but didn't actually power the board on, and that's why the power LED is not on the switch here. So it's in this weird kind of on state. Kind of threw me for a minute when I looked down and I noticed the power light wasn't on. But that makes sense. Okay, the light went off. Flash drive did a little bleep, little blink. And let me switch over to the HDMI input now, or we can at least minimize this a little bit more. And this should just auto boot itself here. It should auto reset. Now the power light came on over here. All the LEDs down underneath the board have lit up. And now, when we look on the screen, we should see the power on self-test succeed as it recognizes the 13th gen chip. The board just made those settings changes where it trains the RAM and the CPU. It applies those changes and resets just like a normal first-time boot, only now with an updated BIOS. Hopefully it now recognizes the CPU with no other changes made. And we will get, I hope, the Gigabyte logo here within about 90 seconds. There it is. There it is, ladies and gentlemen. We'll go ahead and turn off the portable camera. Thank you for that. And that is how that's done. Very, very straightforward, but you must follow the directions precisely. Now, from this point forward, the build would be just like any other build. I would put my Windows 10 or Windows 11 flash drive in, restart the machine, and install Windows as normal. Everything else is the same as it always is on any other build from this point forward. We just had that little difference right there, and a critical one. Disappointed that the information was not so obvious to find, not conspicuous. A Gigabyte site. but very easy to do a quick Google search and to see that the instructions were generic for all 4 of the big motherboard manufacturers, with the differences highlighted, such as the name of the BIOS is different on each manufacturer. You obviously aren't going to name an ASUS board GIGABYTE or whatever the requirement is. In this case, it was gigabyte.bin. I didn't need any of the other files in the zip file that I downloaded that contained the updated flash memory, or updated BIOS flash update. Wordy, too wordy. All I needed was the BIOS file, just like you always see me do, and I had to rename it, which I never have to do. Had to put it into a specific USB port, and I had to use the button to activate that. As you can see, with or without a CPU, with or without RAM, this process will still work. Our results are more instantaneous by having the RAM and CPU in, because it reboots itself and we're in. That's all there is to it. Now, when another generation or other models of the 13th generation chip come out after the first of the year, I don't know if they're already programmed in here or if there will yet be another BIOS we'd have to update to. If I had an older CPU, I could have just simply put that on temporarily. It did the BIOS update in the same way you've seen me do it a million times before. Just go into the BIOS and choose QFlash and load it up. Then swap the CPU out and then it would work. Most of you won't have that option though. And so if you don't have the option, make sure you're buying a board that has the ability to update the BIOS if you're planning to use a 12th gen board with a 13th gen chip, or plan on having a spare CPU handy just to get that done. Or wait a few months so that whatever inventory exists will already be updated. Because where they manufacture these boards, at the time of manufacture, they put the latest BIOS on that day. So eventually the boards will just roll off the line with the latest BIOS that recognizes the 13th gen chips. This is just because of how new everything is. If you want to, be one of the early adopters and mix it with older hardware, this is the process you should expect to go under, to endure, if the board supports that. All right, so that's really what I wanted to cover today. And I appreciate everybody hanging out with me. It was a nice, much calmer, less chaotic live stream today, which I appreciate. And of course, all the viewers will be able to enjoy this video starting tomorrow. It'll be made available. Halloween has started. I see the trick-or-treaters are starting to go up and down the street. So I suppose I better say goodnight now before we get a ton of interruptions. Thanks you guys so much for hanging out with me. Thanks for your support. Appreciate all of you very much. I'll see you all again very, very soon. Just under the wire, XRod666 with a $1 super chat. Thank you, XRod. I'll look forward to seeing you all very, very soon. Thank you to Cam Girl for our close-ups today. And until next time, bye for now. Oh, I should find my creepy outro. Where's my creepy outro? I have a creepy outro. I'm still trying to find it. It's in here somewhere. I told you these are live. You know what? I don't know where it is, but this one's pretty good. So one more time, bye for now.